Good morning, ma'am. Myself, Annansha from 2nd CSC. Roll number is 234G10510. Today's my topic is Dynamic Programming General Method. Subject name is Advanced Data Structures and Algorithm Analysis. Subject code is 23CSC 301. Next topic is Dynamic Programming in General Method. Introduction to Dynamic Programming. Dynamic programming is also known as, it is denoted by DP, is an optimization technique used for solving complex problems by breaking them down into simpler subproblems. It is particularly useful for problems with overlapping subproblems and optimal substructure properties. DP is widely applied in fields like computer science, economics, and bioinformatics. Dynamic programming types of approaches are two types. Top down approach is one and another one is bottom up approach. Top down approach uses are memoization. Bottom up approach uses are tabulation. Key concepts of dynamic programming in general method. Overlapping subproblems occur when the same subproblems are solved multiple times in the process of solving a larger problem. Optimal substructure means a problem can be solved optimally by using optimal solutions to its subproblems. Understanding these concepts is crucial for implementing dynamic programming effectively. This is a Fibonacci tree diagram. Any parent node have only two children, at most two children. Types of dynamic programming. There are two main approaches to dynamic programming: top down or memoization and bottom up or tabulation. The top down approach involves solving the problem recursively and storing results to avoid redundant calculations. The bottom up approach builds a solution iteratively, starting from the smallest subproblems and combining them to solve larger ones. Next one, steps to solve a DP problem. DP means dynamic programming. The first step is to define the problem and identify the subproblems that need to be solved. Next, establish a recursive of the problem to the solutions of its subproblems. Finally, implement the chosen approach, memoization or tabulation, to construct the solution effectively. Start. Define the problem is first one, second one is brainstorm solutions, third one is pick a solution, fourth one is implement the solution, fifth one is review the results. It is finished. Example problem in Fibonacci sequence. The Fibonacci sequence is a classic example to demonstrate dynamic programming. In the naive recursive approach, the same Fibonacci numbers are recalculated multiple times, leading to exponential time complexity. By using dynamic programming, either through memoization or tabulation, we can reduce the time complexity to linear. Problem 1 is the Fibonacci sequence is a series of integers. The first two numbers in the sequence are both 1. After that, each number is the sum of the preceding two numbers. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144 and so on etc. For example, 1 plus 1 equal to 2. 1 plus 2 equal to 3, 2 plus 3 equal to 5, 3 plus 5 equal to 8, etc. The nth Fibonacci number is the nth number in this sequence. So for example, Fibonacci 1 equal to 1, Fibonacci 2 equal to 1, Fibonacci 3 equal to 2, Fibonacci 4 equal to 3, etc. Do not use zero based counting. Fibonacci 4 is 3, not 5. Your assignment is to write a assembler code, Fibonacci, that asks the user for the nth term in the Fibonacci sequence. Your program should then calculate the nth Fibonacci number and print it out. For example, your program should produce the following outputs. Enter Fibonacci term 6. The sixth Fibonacci number is 8. Memoization explained is: memoization is an optimization technique that stores the results of expensive function calls and returns the cached result when the same inputs occur again. This top-down approach helps to avoid repetitive calculations, significantly improving performances. It is particularly useful when the problem has a larger number of overlapping subproblems. This same T diagram of dynamic programming. Tabulation explained. Tabulation is a bottom-up dynamic programming approach that solves subproblems iteratively and stores the results in a table. This method typically leads to better space efficiency compared to memoization in some cases. It is advantageous when the entire solution can be built from smaller subproblems without requiring recursive calls. Common applications of dynamic programming. Dynamic programming is utilized in various applications, such as in algorithms for shortest paths, like digits and Bellman-Ford, and in optimization problems, like the knapsack problem. It is also used in data compression algorithms and machine learning for sequence alignment in bioinformatics. Next point: understanding dynamic programming can greatly enhance problem solving skills in competitive programming and algorithm design. Dynamic programming applications are areas. Areas in subproblems are bioinformatics, control theory, information theory, operations research, computer science or theory, graphics, AI systems, and so on. Some famous dynamic programming algorithms are Bellman-Ford for shortest path routing in networks, Smith-Waterman for sequence alignment, Viterbi for hidden Markov models, Unix-Diff for comparing two files. Next, challenges in dynamic programming. One major challenge in dynamic programming is correctly identifying the overlapping subproblems and optimal substructure of a given problem. Designing a suitable recursive relationship can be non-trivial and requires thoughtful analysis of the problem. Additionally, managing memory usage and computational efficiency can be a concern, especially for large-scale problems in dynamic programming. Dynamic programming solve coding challenges are these ones. Conclusion and best practices of dynamic programming in general method is: dynamic programming is a powerful technique that can simplify complex problems and improve computational efficiency. Practicing various dynamic programming problems can help in recognizing patterns and developing a deeper understanding of the method. Always aim to analyze and optimize both the time and space complexities of your dynamic programming solutions. Next, dynamic programming in general method outlines are: introduction to dynamic programming, key concepts, types of dynamic programming, steps to solve a dynamic programming problem, example problem in Fibonacci sequence, memoization explained, tabulation explained, Dynamic program approaches are top-down approach and bottom-up approach. Top-down approach uses memorization, bottom-up approach uses a tabulation. Common applications are these: challenges in dynamic programming, conclusion, best practices. Thank you for giving this opportunity, ma'am.